Assalamualaikum warahmatullahi wabarakatuh. My name is NABIHAH binti MUHAMAD and I am from UiTM Aeropolis. Today, I would like to present my review paper on characterization and toxicity potential of civil nanoparticles fabricated with proteases of Ananas, Comosus, and Garcinia Mangostana. I will proceed with Chapter 1, which is Introduction. The development of green synthesis of civil nanoparticles using diverse natural resources such as flowers, fruit extract, plants, leaf, microorganisms is an emergent study of nanotechnology. The extract from plant and fruit function both as reducing and stabilizing agent of civil nanoparticles green synthesis. According to the study, the optimization of temperature and pH can enhance the formation of civil nanoparticles. Different methods are used in the synthesis of nanoparticles as shown in the diagram. Physical and chemical methods use toxic composite or need vast amounts of energy to synthesize civil nanoparticles. The current synthesis of civil nanoparticles research use methods of chemicals such as borohydride and elemental hydrogen, which have potential threat to both environment and people health. Next is the significance of the study. Biosynthesis of civil nanoparticles using natural resources can reduce the toxicity production. Furthermore, the use of Ananas, Comosus, and Garcinia Mangostana waste can reduce the production of solid waste, which has increased by time. The objectives of the study are: first, to review the characterization of civil nanoparticles fabricated with proteases of Ananas, Comosus, and Garcinia Mangostana extracts through visual observation, UVVs, and scanning electron microscopy (SEM). Second is to review impact of pH and temperature on civil nanoparticles fabricated with proteases of Ananas, Comosus, and Garcinia Mangostana extracts. Third is to review the toxicity potential of civil nanoparticles fabricated with proteases of Ananas, Comosus, and Garcinia Mangostana extracts. Next, I will proceed with the Chapter 2, which is the literature review. Nanotechnology is a part of modern technology which has been increasingly explored and researched in the science and technologies nowadays. For instance, nanotechnology applies in the next stage of production of genetically modified harvest, animal production, chemical pesticides, and farming techniques. Silver nanoparticles are the materials that is small in size within the range of 1 nanometers to 100 nanometers. The formation of silver nanoparticles is through the reduction of silver nitrate produces metallic silver, and as this metallic silver gains electron and come across the excess of silver ion and gradually form the silver nanoparticles. Both pineapple and mangosteen are tropical fruits that are utilized in medicinal field. The phytochemical compound in them causing the reduction of silver ion. Through the visual observation of Ananas, Comosus, and Garcinia Mangostana silver nanoparticles, the solution color changes from pale yellow to brown, which indicate the formation. The color changes because of the reduction of silver nitrate to silver nanoparticles occur. This table shows the result, which indicate the Ananas, Comosus, and Garcinia Mangostana silver nanoparticles color changes to brown. Next is the characterization through UVV spectra. If the peak is at the range within 400 nanometers to 500 nanometers, it indicates the formation of silver nanoparticles. From this table, the Ananas Comosus silver nanoparticles highest wavelength is 485 nanometers, while Garcinia Mangostana silver nanoparticles highest wavelength is at 433 nanometers. For information, SEM is used to identify the presence of silver nanoparticles and analyze the size and structure of silver nanoparticles. The table shows that Ananas Comosus silver nanoparticles is the smallest at 12 nanometers, while Garcinia Mangostana silver nanoparticles the smallest within the range of 15 to 20 nanometers. This shows that they are small, spherical, and stable in size. In the pH optimization, the variation of pH contributes to the changes in the phytochemical charge, which then affects the stability and reduction of silver in the synthesis process. This can be proved by the tables, as it shows that the wavelength is different at different pH, where the basic state increases the formation of silver nanoparticles, while acidic state suppresses the formation of silver nanoparticles. Next is the temperature optimization. The higher temperature produces smaller nanoparticles, while lower temperature produces larger nanoparticles, as shown in the table. The higher the synthesis temperature at 75 degrees Celsius for Garcinia Mangostana and 90 degrees Celsius for Ananas Comosus silver nanoparticles, the smaller and stable silver nanoparticles form. The next part is the toxicity potential of Ananas Comosus and Garcinia Mangostana silver nanoparticles. Presence of flavonoid, tannins, and alkaloid in plant could also be considered for its toxic properties. If the concentration of silver nanoparticles increase, the toxicity can increase. From this table, the Garcinia Mangostana silver nanoparticles show slightly toxic toward the human keratinocyte cells, but is toxic to the human cancer cell. The last part in this presentation is chapter 3, which is the conclusion and recommendation of this study. To conclude this review, the SEM showed that the size of the silver nanoparticles is within the range of 1 nanometers to 100 nanometer. Second, the size of Ananas Comosus and Garcinia Mangostana silver nanoparticles differed due to the optimization in pH and temperature. In conclusion, their silver nanoparticles have low toxicity, high thermal stability, and low volatility. It is recommended that more techniques used in the characterization of silver nanoparticles to gain more accurate results, such as transmission electron microscopy (TEM), X-ray diffraction analysis, and also FTIR analysis. And lastly, it is very recommended to use the brine shrimp lethality assay to test Ananas Comosus and Garcinia Mangostana silver nanoparticles at different sizes. That's all from me. Thank you for watching this video.